Hey everyone, welcome back to Number Buddy. My name is Buddy. Today we're going to be continuing with trigonometry. Specifically, we're going to start learning about what the trigonometric functions actually are. Sine, cosine, tangent, etc. Let's get into it. So we've learned how to take any angle, put it on the xy plane, whether it's in the first, second, third, or fourth quadrant, and whatever direction that angle ends up pointing, we've learned that you take the end of it and draw a line straight down or up, but straight vertically to the x-axis. And that's how we form this right angle here. We've learned this is our reference angle, and we've learned that a y value represents the height, an x value represents a horizontal length, and then our hypotenuse, which we can call z or c, you may see at different places called different things, but our hypotenuse is the resulting long side across from the right angle. So what are we talking about when we're actually talking about trigonometry? You may have seen things like sine, cosine, tangent, but you may not know what they mean yet. So let's use one of our special right triangles that we learned about last time. We said if you have a right triangle where one of the angles is 30 degrees, we know the other angle is 60 degrees. If you aren't sure why we know that, go back to the first lesson that we talked about that, and if you're still not sure, then we'll make a geometry playlist. Let's start with sine. Technically, if you write sine, it looks like this. It has an E at the end of it. Whenever we're writing with it in a mathematical equation, we leave off the E and just call it sine of something equals something else. So, what is this something that you're putting in, and what is the output? Well, what we're putting in is always sine of an angle. And the resulting thing that we're going to get after the angle is a ratio. The same thing is true for cosine. Cosine of something equals something. Tangent of something equals something. These are all taking in angles. So let's say I wanted sine of something about this triangle. What you would be doing is taking the sine of an angle. So for instance, sine of 30 degrees, if 30 degrees goes into our sine function, what comes out? I said it's a ratio, right? Well, I also said it's a ratio on cosine and tangent too. So the only difference between a sine function and a cosine function and a tangent function is what ratio you're talking about. A ratio of what to what, right? A ratio always has two things. It's a ratio of this to that, a ratio of one thing divided by another thing. But in all of these functions, you're taking the ratio of sides, of one side to another side. The only difference is which side you're taking the ratio of in each function. Sine is the ratio of opposite side over your hypotenuse. Let's take a look at what I've drawn in here. If we're looking at sine of 30 degrees, this is the angle we're looking at. So once we pick an angle that we're looking at, the ratio is always from the perspective of that angle. So if we want the opposite side to our 30-degree angle, since we've decided we're taking the sine of 30, the opposite side looks that way. Does that make sense? It wouldn't be any of these sides. It wouldn't be this side or this side. Each of those sides is included in that 30-degree angle. The 30-degree angle is the angle between those two sides. The only side that can be opposite to 30 is the side that's not included, that's defining that 30-degree angle. Your opposite side here is going to be this side there. That's opposite of 30 degrees. If we have this triangle on an XY grid, this opposite side to 30 represents the y height that this side goes up to. So even though the sine of 30 is always going to be the opposite side over the hypotenuse, in this particular case, we have the sine of 30 degrees equals our y value over the hypotenuse, okay? If you watched the video before this of what to learn instead of memorizing the unit circle, you might remember that the 30, 60, 90 triangle is a special right triangle. And this special right triangle always has a ratio of 1 to root 3 to 2. So actually, if we're looking at the sine of 30 degrees, we know that the sine of 30 degrees, no matter how big this triangle is, the triangle always works in ratios. So we know that this opposite over hypotenuse is always going to have to be 1 over 2. Now, that doesn't mean that the side across from 30 degrees is always going to be a length of 1. This length could be 10, but that would mean this length would be 20. This length would be 10 root 3, but then we see if we took the same sine of 30 and we took opposite over hypotenuse and we said, okay, starting from 30 degrees, opposite side is 10, over the hypotenuse side is 20, this still cancels out to 1 over 2. So we've learned that sine of an angle is opposite over hypotenuse. So let's say now we want to look at what is the sine of 60 degrees. Okay? We could redraw a new angle, and a new angle that goes up to like 60 degrees like this, right? And then draw downwards and so on, right? But we actually have this triangle already here, because a 30, 60, 90 triangle has an angle of 60 in it already. The only thing is, now we have to look from the perspective of that angle. So because we're doing sine of 60, we're still going to be doing opposite over hypotenuse, except the perspective is now changed. Now we're not doing the opposite side to 30 degrees, we're doing the opposite side to 60 degrees. So what's that going to be? So that's going to be this side here, this root 3. So we're still doing opposite over hypotenuse. The only difference is the opposite side is now root 3, and the hypotenuse is 2. Does that make sense? We're doing the opposite from there. We went that way. Cool? We're always going to be dealing with ratios. Okay, so if sine is the opposite over hypotenuse, what is cosine? Let's use this color. Cosine of an angle, any trig function, we're still doing angle as our input. Angle is still our argument. Okay? So let's say again, we want to do cosine of 30 degrees. We're going to start with that lower angle again. Because we're doing cosine, we're not going to do the same thing. We're not going to do 1 over 2 again. Cosine is not opposite over hypotenuse. Instead, cosine is adjacent over hypotenuse. So what does adjacent mean? Well, if we look at this 30-degree angle, an angle is created by two lines that meet somewhere. And the angle is the degrees or radians of the separation between those two lines, right? In this case, we have 30 degrees. But that angle has to be made by two lines that meet, okay? Well, the two things that meet to form this 30-degree angle are that side and that side. One of those sides is the hypotenuse. So when we say adjacent, we are not talking about the hypotenuse. We're talking about the other side that is touching the angle, but that is not the hypotenuse, okay? So adjacent in this case is going to be this side down here. This is adjacent to 30 degrees, but not the hypotenuse. So the ratio of the adjacent side over the hypotenuse is always going to be root 3 over 2 for a 30, 60, 90 triangle, okay? But if we were looking at the cosine From this perspective, from the 60-degree perspective, the adjacent side in this case is this, right? Because these two lines form the 60-degree angle, but this side is the hypotenuse. So the adjacent side is 1. Okay, so the last one we have to learn is tangent. When we talk about tangent, we're talking about opposite over adjacent side. So if we wanted to know the tangent of 30 degrees, well, again, we're starting from 30 degrees. The opposite side is 1. From 30 degrees, the adjacent side that's not the hypotenuse is root 3. And again, if we looked at tangent from the other perspective, from 60 degrees perspective, this would be the opposite side would be root 3, and the adjacent side would be 1. So root 3 over 1, which is just root 3. Anything over 1 is itself. And there we have it. It's just the ratio of those sides. Now, I'm only working with 1, root 3, and 2, because that's the ratios of a special right triangle. So I'm using the 30, 60, 90 triangle as an example, because we hopefully learned about it last time. Your 30, 60, 90 triangle isn't always going to be 1, root 3, 2 exactly, but it will be numbers that have those ratios. 10 to 10 root 3 to 20, or 50 to 50 root 3 to 100, and so on. All right, so I have here a quick reference sheet that gives you sine, cosine, and tangent, and I like to write them this way because it reminds me that sine, cosine, and tangent all have an angle that you're putting into them. And then from the perspective of that angle, what is the opposite over hypotenuse in the case of sine? Or what is the adjacent over hypotenuse in the case of cosine? And then what is the opposite over adjacent in the case of tangent? If we look at them this way with our reference triangle, we can see what corresponds to what. We always want to be remembering that it's from the perspective of the angle that we're putting as an input into your cosine or sine or tangent function. Cool? Hopefully you followed along with that. Hopefully it wasn't too difficult if you were following along with the last videos, but let me know if there was anything that I glossed over that you felt needed a little bit more explanation. I'll see you next time on our trig series, and until then, my name is Buddy. Keep learning.